It's amazing to see what we're able to accomplish with technology in this day and age. We don't very often encounter inventions that we can point to and say with certainty that it will change the future. Howdy everyone, my name is Javier Lopez. I'm a sophomore mechanical engineering major studying at Texas A&M University, and today I will be telling you why 4D printing is that one invention that you can point to at and with certainty say that it will change the world. Now 4D printing, although it is still something that it's in development and developing, and it has a lot of constraints that we have yet to discover, scientists are still working very hard to implement this technology into our lives. But what exactly is 4D printing? Well, 4D printing is a new and fascinating technology, but it is very complicated nonetheless. In a research study done by Bajan and others, released in 2020, they mentioned how 4D printing is a new engineering where you use bioengineered materials and have them react to certain stimuli. Your object, once 4D printed, will be able to react to certain stimuli. The way it reacts, whether it stretches, curls, bends, or whatever else you want it to do, and what it reacts to, whether this is light, temperature, or water, all depends on the object's initial design and the material's components. In another study done by Champo and others, also released in 2020, they mentioned how there are different materials being tested for 4D printing. Along these materials, we see hydrogels, smart hydrogels more specifically. And the reason smart hydrogels are gaining a lot of growing attention is because of their availability and the way that we're able to manipulate them and have them react the way we want them to react and what we want them to react to. Now, 4D printing shows a lot of promise, but there are still a lot of factors that hinder us from advancing and developing too quickly. Now, what does 4D printing really consist of though? Well, you see, 4D printing is very similar to 3D printing, but it has more focus areas. Now, you may be imagining or wondering, thinking to yourself, what is the fourth dimension we're talking about? Well, in 4D printing, our fourth dimension that we're talking about is time, because in time, our objects will react with some stimuli and transform and really do the task that we want it to do. Now, 4D printing starts in a computer-aided design software, just like 3D printing. About 6 or 7 years ago, MIT granted Skylar Tibbetts, one of their professors, a grant to start the MIT Self-Assembly Lab. The MIT Self-Assembly Lab focuses mostly on 4D printing, and according to their website, they have been working with Stratasys, a company that focuses on making 3D printers, and Autodesk, the biggest CAD software in the world. However, in an article written for the magazine Scientific American back in 2014, Campbell, Tibbetts, and Garrett mentioned how some problems, some challenges go way beyond the CAD, the computer-aided design. This is because we still know so little about the subject of 4D printing. We still need to figure out how some materials react, how some objects will react, and really be able to design them the way we want them to. And some of this happens before we actually design our object through the computer, and also a lot of it is testing afterwards to find out more about the object's reaction, its recovery time, and all the factors that it is affected by. Now, an article published on the website Sculptio mentions how material production is complicated for 4D printing. This is because material availability and cost all varies differently, but the same article also mentions how once we are able to truly understand how these materials react and what they react to, this will be a revolutionary discovery. Now, 4D printing testing takes a lot of time, again, because we know so little about the subject, so it's hard to move on fast from these early stages of testing. However, whenever we start doing more research with 4D printing, the future really starts to look brighter. And so this really leads me to my last point, that there is a lot to expect from 4D printing. In 2013, Scholar Tibbets did a TED Talk in which he mentions how he sees a lot of promising uses for 4D printing in the future. I'm going to borrow two of his examples. Imagine water pipes. Usually when we have to change a water pipe, we have to excavate underground, take out the pipes, put new ones back in, and cover it. Well, what if we didn't have to do that? If we could really just have a water pipe that adapts to the water flow. For example, when there's less water, the circumference of the water pipe changes, it becomes smaller in order to increase the water pressure, and vice versa when there's a bigger water flow. And then also imagine if these water pipes could, later on with a new technology along with 4D printing, self-repair in case there's damage. We won't ever have to dig underground again, meaning that we save a lot of time and money. Now, another more extreme scenario is going to space. We really can't go that far out into space because we don't have the technology or manpower to. But what if we could send various components of a space station into space further away, and then once they reach their destination, self-assemble into their own and release robots to discover and search the area. Now, another article from the American Society of Mechanical Engineers, written in 2014 by Crawford, mentions how not only will engineering benefit from 4D printing in the future, but all of the industries around the world, they will be able to save so much time, energy, and money once this becomes available to the mass public. Now, today I've talked to you about a new technology that will really change our lives. That is 4D printing. Although this is a new technology that demands a lot from us, it requires a lot of work and testing, it will truly revolutionize the world and all of our lives. I truly believe we should start preparing for the changes to come in the future because, as Scholar Tibbets said in an interview for an article for the magazine Popular Science back in 2015, our goal and our mandate is to invent the future. Thank you. And here are my note cards. 1, 2, 3, 4, and 5. And nothing in the back. Oops. Thank you.